So in the last lecture, we have already obtained the input characteristics of our BJT. So I'm continuing from that lecture. Okay. So now we have to obtain our output characteristics of our BJT. So to remember this particular characteristics of our BJT in common emitter configuration. So this is our output characteristic. So you can remember that onto this particular x-axis, we are having common emitter means collector emitter voltage, okay, that we have to vary from 0 to 20 volt, and this different curves has to be obtained for different values of base current. Okay, so let's say the base current will be equals to 0 microamperes, then 10 microamperes, 20 microamperes, and so on. So this way we have to keep on obtaining this particular family of curves, right? And here we have to plot the IC. Okay, these values are nothing but your different values of our collector current by varying the collector emitter voltage, okay, for different values of base current. So let's begin how to obtain this particular output characteristics. So to obtain this output characteristics, as I told you that we have to take this one. Okay, first of all, we have to keep on varying the collector emitter voltage. Okay, so this is our collector emitter voltage that we have to vary. So that value will be equals to 0 volt, 0.25 volt, 0.5 volt, 1 volt, 2 volt, 3 volt, 5 volt. After 5 volt, we can increase the step size like 7.5 volt, 10 volt, 15 volt, 20 volt, and so on. Okay, so they should be obtained for different value of base current. So first value should be with respect to base current equals to 0 amperes, and then we have to keep on varying the base current. Okay, first we have to obtain this entire table. We have to fill this entire table for base current corresponding to 0 microamperes, and then we have to perform or repeat the experiment for different values of base current. Okay, so how to perform this one? Just go to your circuit. So when we go to the circuit, what we have to first perform is we have to start the experiment right from the 0 volt. Okay, so if you make it 0 volt, obviously this value will be equals to 0. Okay, when we are making it 0, or we have to make the base current equals to 0. To make the base current equals to 0, we have to make it 0, nothing else. Okay, once you will make it everything equals to 0, obviously when you simulate this circuit, everything will be equals to 0. So just in the first one, okay, what we have to do is just you take this one. Okay, so in this IC will be equals to 0 when collector emitter voltage is equals to 0. Now we have to make the collector emitter voltage equals to 0.25, and we don't have to vary this IB. It should be equals to 0 microamperes only. So once you will make it 0.25, so first you make it 0.25, stop it, and then you make this particular collector emitter voltage equals to 0.25. Okay, so you are making 0.25 volts. So once you will make it 0.25 volt, then something we are getting here. So what the values are, you can see here. You can see this particular value is of femtoamperes. Obviously this value is very small. Okay, very small current. Okay, so it is can be considered as equals to 0. Okay, and here you can see what is our collector current. Okay, so our collector current is 252.576 picoamperes. Okay, so this current is very small. Okay, you can see it should be in the order of milliamperes. Okay, so this value is very small with respect to milliampere. So what I can do is I can put this value equals to 0. So just to discard this negative sign. Okay, because while plotting we can take care of that. Okay, so negative sign indicates that current is actually flowing in this direction. Okay, so this value is equals to 252.576 picoamperes, but I will make it equals to 0 because this value is very small. Okay, and this potential across collector emitter terminal is 0.25 volts because it is directly connected. You can see here. Okay, it is directly connected. So it is 0.25. So just note down these values. This value is equals to IC equals to 0. Now when you make it 0.5 volt, just make it 0.5 volt. Stop it. Okay, just make it 0.5 volt. Once you will make it 0.5 volt. Okay, now here you can see once we'll make it 0.5 volt, here you can see it is value is equals to 499.6 picoamperes. Again you can say this current is femtoamperes. So this current is very small. Okay, this current is very small. Okay, you have to remember that this base current should be equals to 0. Okay, because we have to obtain the curve for base current equals to 0 current. Okay, so femto amperes current is very small. Okay, so it is obviously 0. And now this current is again very small with respect to milliampere. Okay, so again you can note down this value. This value can be 0. Okay, or otherwise we can note down a very small value, but I think because this value is very small, we can make it 0, no issues. Okay, so now you can make it 1 volt. So once you will make it 1 volt, okay, you can make it 1 volt, just execute it. Okay, now again what value you are getting is you can get this value equals to 0.999 microamperes. Okay, 0.999 microamperes. So or you can say it is 0.001 milliamperes. Okay, 0.999 microamperes, or you can say it is 0.001 milliamperes. So we can make it 0.001 milliamperes. So just you make it 0.001 milliamperes. Okay, similarly you can again keep varying these values. Okay, just stop it, just make it 2 volt. Okay, if you make it 2 volt, if you run this one, okay, you can see again it is in the femto amperes. Okay, that current is very small. This value is 1.998 nanoamperes. Okay, so how much it can be written as? It is something around 2 nanoamperes. So 2 nanoamperes is same as how much? It is 0.002 milliamperes. Okay, so you can make it 0.002 milliamperes. So it's very small current. In fact, it's very small current. So we can make it 0.002 0.002 milliamperes. Now, similarly, you have to perform this experiment. You have to keep on varying these voltages. In this step size, we have to change the VCE value. Okay, in this particular step size, and then we have to note down all the values of ICs. So I have already performed this experiment. So you just go to this one. So I'm just going to this one. Okay, and then you have to bring this all data. Okay, I'm just copying this one. Okay, so you can verify all these results, okay, by performing the experiment by your own. So just you bring it this particular data, okay, here, sorry, so just copy this data only. Okay, just you copy this data, just you copy this data, go to this and then paste it over here. Okay, so the value is around this values. Okay, so just to make the measurement carefully, I think there I have written 0.001, but it is, if you make the measurement carefully, you will get that when 2 volt is there, then the value is 0.001. Just to make it carefully, if you do the observation carefully, you can get all these results. Fine. So once you obtain these results, now what the next we have to do is we have to change the base current. Okay, we have to change the base current 10 microamperes, and we have to ensure that this base current should not vary when we change the collector emitter voltage. Okay, that we have to ensure. It is a very important point while performing the experiment. So what I'm saying is, first of all, this should be equals to 0 volt. When obviously when it is 0 volt, then it is equals to, let us say, if it is making, if you are making it as equals to 0. Okay, and if you want to make it like certain values, okay, like 10 microamperes. Okay, so I have already done this experiment. You can see here that to make it equals to 10 amperes, 10 microamperes, IB equals to 10 microamperes, your V input should be equals to 1.58. Okay, so what I'm doing here is just go here, because we have to make this current equals to 10 microamperes. So I am going to make it 1.57. Okay, just make it 1.57 volts, and now you can execute this model. Okay, here you can see it is 9.932 microamperes. Okay, so just to go to this, okay, you can see it is 1.58. Okay, so just make it 1.58. So if we make it 1.58, so you will be getting near about 10 microamperes. So first we have to make it 10 microamperes. Okay, now it is 10 microamperes current is flowing through this base. Okay, so now this input condition is we have set the input condition. Now for this 0 volt we have to measure this currents. Okay, so these values are very small. You can see it is 7.974 microamperes. So you can say this value is very small. Okay, very small values. Okay, and this voltage is almost picovolts, or it should be 0. Okay, so you can make it 0 volt, right? So I'm just making over here, just go to this, and then here you have to note down this value. So you can just, for your reference, at what value of V input your I will be equals to 10 microamperes, that you can note it down for just for your reference. This value should not be plotted. Okay, we have not to plot this particular value. Okay, so just note down the collector current. Collector current will be equals to 0. Now, when you vary this particular voltage, okay, you remember when we vary this voltage, let us say when we vary this voltage 0.25, okay, 0.25, then in this case we have to observe that this base current should not be varying. If it is varying a lot, okay, then again you have to bring it back to 10 microamperes, because we want to obtain the output characteristics corresponding to IB equals to 10 microamperes. Okay, so if we execute it, you can see that this value is going back to 9.151 microamperes. So now it is reducing. Okay, this value is reducing. As you know that there is a early effect. Okay, so if you see that there is a base width modulation, if you aware of that, okay, because of certain phenomenon within the transistor that may take place, and that will bring down this current. Okay, so again we have to bring back this current to 10 microamperes, because we want to obtain the curve for 10 microamperes. So to bring back these values to 10 microamperes, again we have to increase this particular V input. Okay, so to increase this value, at what value we are getting this 10 microamperes, I have already noted down, it is 1.67. Okay, so just to go and make it 1.67, so go into the model, make it 1.67. so once you will make it 1.67, okay, while doing the experiment on breadboard, again you have to take care of the same thing. Okay, it is not like only in the multisim we are getting these results. Okay, even if you conduct this experiment on the breadboard, again you have to take care that this value should not be varying. Okay, so now again it is almost equals to 10 microamperes. So now because of this, now you can measure these currents. Okay, this collector emitter voltage is 0.25, and now this current is 2.832 milliamperes. So just note it down. So this value is equals to, here it is 1.67 we have made, and then this value is 2.832 milliamperes. So it is in the milliamperes. I have not written over here, but this current must be of the order of milliamperes. Okay, remember that. So this current is 2.832. Okay, so this is 2.832. So this is our value. Now again we have to make the VC equals to 0.5 volt. Okay, so just make it 0.5 volt and keep observing this. Okay, if you make it 0.5 volt, okay, just make it 0.5 volt. So once you will make it 0.5 volt, first we have to check whether this current is varying a lot or not. This is our base current, but it is still 10 microamperes. When it is not changing, so we don't have to disturb this value 1.67. It should be still 1.67, because we want 10 microampere current to be flowed through this particular base terminal. Okay, now for this 0.5 volt of collector emitter drop, we have to measure this current. It is 2.86 milliamperes. So just note it down, 2.86. It is 2.86 milliamperes. Okay, now we have to make it 1 volt. VC is equals to 1 volt, and now onwards, even if you change the collector emitter drop, it will not change. Okay, the 10 microamperes, it will remain 10 microampere. Okay, we don't have to bother about this. Okay, initially we have to bother about this when it is 0 volt, and then we are changing this value from 0 to 0.25. Okay, only that time we have to take care. Okay, otherwise you can perform this experiment easily. Fine. So if you keep it 1 volt, so just you stop it, you just change this value 1 volt. So once you will make it 1 volt, okay, then if you execute it, here again it is still 10.022 microamperes. Here you can see the current is 2.879 milliamperes. So you have to note down 2.879 milliamperes. Fine. So this way you can conduct your experiment. Okay, so just I have conducted this experiment, so I am just noting down this particular values. So you just take this value. Okay, now you can copy and paste these values over here. I have written here 0 because that value is very small, but if you want to accurately write that value was 0.008. Okay. This way you can conduct your experiment. So similarly, all other experiment you have to perform for IB equals to 20 microamperes, IB equals to 30 microamperes, IB equals to 40 microamperes, 50 microamperes, and so on. You can go up to 90 microamperes or 100 microamperes if you want. Okay, so just I'm copying and pasting all this data. You can remember these are the V in values. Okay, 2.6 and 2.7 volts. Here it is 3.62, 3.71 volts. Here it is 4.62 and 4.72 volts, 5.63 and 5.72 volts. Okay, just to keep the values equals to 20 microamperes, 30 microamperes, 40 microamperes, and 50 microamperes when we are changing the VC values. So that we have to take care. So just I'm copying these values, okay, into my model. So into this particular table, okay, these are the values, okay, these are the values. So we can take all this data over here. You can perform this experiment. If I conduct this experiment entirely onto, if I make the video, then it will be a very long video. So I am not doing that. So please try to understand that one, and then you can just verify all this data. You will get this data easily, okay, from your experiment. So I'm just copying and pasting this all the data, okay. So this is my final data responding to IB equals to 50 microamperes. Okay, so you can continue your data. Okay, you can make it IB equals to 60, 70, 80, 90, up to 90 you can take. So after taking this all the readings, okay, all the readings, what we can do is we have to again go for the plotting. So just you select the VCE, okay, just select the VCE, then you have to select the IC current. You have to select all the IC currents, okay, responding to different values of IB. Okay, so after selecting this one, you can go for the plotting. After selecting this all curves, okay, then you can go for the plotting. Go to the insert, go to the chart, okay. Again, something is missing. Some data have not been selected properly. Okay, so just let me see if all the charts are. So just try to select once again. Okay, it may be a certain problem. Okay, so I'm just selecting this one. Okay, so this is our VC value. Then we have to select this one, then this one, then this one, then this one. All the columns you have to select properly, and then you have to go to the charts. Okay, so here you are getting the recommendations. Okay, you have to properly choose which particular plot is of your importance, like this one. Okay, this is our you can see this is not the required chart, because you know that onto the x-axis we want collector emitter voltage drop, and then we want IC current. Okay, so you just select another one, this one. Okay, now you can see here we are getting the collector emitter drop because we have taken this value from 0 to 20 volt, and then a different family of curve we are able to get. Okay, so this is our common emitter output characteristics. So in this particular graph, onto the x-axis we are having the collector emitter drop, and here we are having the collector current. Okay, and these are the curves corresponding to different values of IB. Like this blue one at the bottom is IB equals to 0 microamperes. This is 10 microamperes, 20 microamperes, 30, 40, and 50 microamperes, and so on. So if you want to continue your curve, if you want to continue your experiment to obtain this type of curve, you can do it. You will definitely get these curves also. Okay, these curves you will also get if you keep on doing the experiment. Okay, you have just to make IB equals to 60 microamperes and 70, 80, and so on, and then you can plot the entire characteristics. Okay, so I hope you must have enjoyed this video. You try to perform the experiment, okay, by having this particular circuits, and I hope this must be understandable. So thank you for watching, and try to implement this experiment by your own by just seeing this video. Thank you for watching.